All right, kiddos, quick review here of the practice benchmark you just took on motion graphs. I know that's one thing that it seemed like we need to go over probably the most. And I told you at the beginning of the quarter, this will be the toughest thing that we did. So again, motion graph review for the benchmark coming up. So let's scroll on down here. Below is a distance time graph that shows the motion of a student on a walk. What statement best describes the student's motion? Okay, so we can kind of take a look at our answers here. The student is going faster and faster in the last 2 minutes. If we look down here for C, look at this one here. So I'll look at the last 2 minutes. Is the student going faster and faster? Not really. This is technically because it's the same slant and the same slope there, and actually is going the same speed, so that's not the answer. The student starts out moving very fast, slows down in the middle of the walk, and then speeds up again. I don't see starting out fast and then slowing down and speeding up necessarily. The student walks up a hill. I'm going to just stop there. We all know that these are not hills. These are not flat roads. So B is that misconception that we actually all talked about when we were doing that. The student walks slowly at first, increases their speed. Now, I know that this line is a little faster than this one because of how steep it is. Stops, yep, they did that, and then very quickly returns to the starting point because this is a distance time graph. That's exactly what's going on in this one. So hopefully, when you got this one, you answered A. Scrolling on down. Student went on a walk, kept track of their time at distance. The data is displayed on the graph. What best describes the student's walk? Now, again, if we do the things that we're supposed to do, the first thing we do is, what kind of graph is this? This is a distance time graph. And when I see this, I know that this is constant speed. I know that this is returning to the starting point. So I need an answer that looks very similar to that. We know it's not A. The student did not go up a hill and down a hill. The student walked very quickly at the beginning, but then slowed down. I don't see anything about slowing down. This is not slowing down. This is not a speed time graph. The student walked slowly at the beginning and faster at the end. Actually, these two slopes look about the exact same. So he's walking the same speed away from the starting point and to the starting point. The student walked at a steady pace and then returned to the starting point. Hopefully when you answered this one, you answered D. Moving on to the next one. This graph shows the movement of an earthworm. Now, don't let this confuse you. This says position time graph. We all remember that position time and distance time are the exact same thing. So let's go ahead and take a look at our earthworm here. Gavin and Maddie observed an earthworm crawling on the sidewalk for 4 minutes. When did the earthworm move the greatest distance? Well, we know that between 1 and 3, the earthworm didn't move at all. I don't know what I just did there because this is at rest. So if it has anything with 1, 2, or 3 in it, then that is not the case. So between 1 and 2 and between 2 and 3 cannot be the answer. So between 0 and 1, it moved 20 centimeters. Between 3 and 4, it moved 10. So I know that between 0 and 1 is the furthest, and so the answer to this one is A. Moving on to the next one, if I can get my computer to cooperate here. We've talked about this one in class, and again, even if you got to this and you kind of forgot what you were doing, I think you could probably reason your way through this one. This is the motion of a cheetah, a human, and a pig. We remember that the steepest line is the fastest object. So it looks like the pig is the slowest, even though his line is the longest. It looks like the human is the second slowest, and we know that the cheetah is the fastest, and that's just common sense. The pig is traveling at a faster speed? No. The cheetah, the human, and the pig all traveled at the same speed. If they traveled at the same speed, their lines would be the exact same steepness, so that's not the answer. The human is traveling at a faster speed. Well, the human is not. It's faster than the pig, but not faster than the cheetah. The cheetah is traveling at a faster speed because it reached the 500-meter mark fastest and in the shortest amount of time. That is correct. So we know that the answer to this one should be D. And we've had this one before in practice and on a test. So hopefully you remember this one as you were going through it. Scrolling on down to the next one here. This graph shows the change in position of an object over time. And it already tells you in the answer that this is a position time graph. So we know that this is a distance time graph. And it looks like the object went at a certain speed, kind of slowed down a little bit because this is, again, a little less steep than this, and then started back towards the starting point. And we know that the object does not remain at rest. We know that it does not go faster over time. I don't see any curves in there. It's definitely not staying at a constant speed throughout the entire thing because there's 4 different speeds on there. But we do know for 100% fact it returned to the starting point. I don't think that that's a very tough question. They're trying to throw some things in here that sound normal. Constant speed, getting faster, or acceleration, remaining at rest are all answers that we have seen before on position time graphs and distance time graphs, but it's not the answer to this one. So we'll move on to the next one. This graph shows the motion of an object. It's a huge graph, by the way. So here's the motion of our object. Looks like the object moves. It stops between 4 and 5, and it continues to move further away, actually 350 meters away from the starting point as we go through there. Between which 2 hours was the object? Well, there we go. There's the words at rest. I know it's between 4 and 5 because we actually talked about that before we even looked at the question and the answers. So your answer to this one is B, because right here it is at rest. That's between 4 and that's between 5. So the answer to this one is B. Moving on to our next question. Below is a graph displaying the speed of a car. What best describes the time the driver began applying the brakes? Now, again, this should kind of give you a hint here. The speed of a car. This is a speed time graph. So every one of these things means something different. This is no longer constant speed. This is acceleration. This is no longer at rest. This is constant speed. This is deceleration, not going back to the starting point. And this is acceleration, because remember, it's a speed time graph. What best describes the time the driver began applying the brakes of the car? Well, what happens to a car when we apply the brakes? It slows down. It decelerates. There's only one spot on here, and that would be from 20 to 30 when the car could be of hitting their brakes. It does not start hitting its brakes at 10 seconds because it's going at constant speed. It does hit its brakes here. It certainly doesn't hit its brakes here because it starts to speed up. So your answer to this one is B. Hopefully you got that one right and you didn't get tricked into continuing to answer things about a distance time graph, which is something I can see them doing. Number 8, the graph below displays the motion of an object. Again, this is a distance time graph. Okay, don't let it trick you just because we keep kind of bouncing around. What statement best describes the motion of the objects from 3 to 4 seconds? So from 3 to 4. Well, it's at a constant speed and moving away from the starting point. So I like this answer. It's definitely not decreasing speed. It's not moving backwards, and it's not at rest. So these 3, none of these make sense. It's definitely A. A is your answer. It's moving at a constant speed, which, as we talked our way through that, we kind of knew the answer before it even started. Moving on. 2 toy cars are being raced down a ramp. A graph is here representing their motion. So I see car 1 and car 2. If they were racing to the 30-meter line, car 2 is definitely faster. What explains the results of the race? Car 1 traveled the fastest. Well, I know you might be thinking, well, this car stopped. But again, think about who has the steeper line. Car 2 has the steeper line, so it's not A. Car 2 traveled the fastest. I know it might be tempting to say car 1 traveled the farthest distance because it looks like the line is longer. But think about this. Car 2 actually went 30. Car 1 only went 25, so that's not true. And then that also makes D false as well, because car 2 did not travel the shortest distance. It traveled the farthest and had time to sit there and wait. And he's still waiting on car 1 to get there. So the answer is B, car 2 traveled the fastest. Moving on down to our next one. The graph below represents a car that's traveling. Again, it's a distance time graph. This car is moving at a constant speed. We can tell that from the graph. If this car continues to travel at there it is, constant speed, what can be predicted about the distance the car will travel in 2 hours? Let's find out how far this car has gone in 1 hour. So this is in minutes. So here's 60 minutes. And it looks like the car has gone 60 miles in 60 minutes, which is 60 miles per hour. How far would it go in 2 hours? It would go 120 miles. It's going 60 miles an hour for 2 hours. You could even draw a DST triangle with that one if you needed to, although I think that's one you could probably do in your head, but maybe not. Again, you have a calculator. Use that as well if you need to. Moving on down to our next question, question 11. The graph below shows two delivery trucks traveling on the same highway. Now, I know that truck A is definitely moving a lot faster than truck B before I start, but let's just figure out what the question is. What describes the speed of the two trucks? Truck A is slowing down and truck B is speeding up. I don't see any curved lines on this distance time graph, so there's no speeding up and slowing down. Truck A is speeding up and truck B is not changing speed. I don't see an answer to that one either, because that's not what's going on here either. And then the answer for C says truck A is not changing speed and truck B is slowing down. Now, when I look at this, I have to ask myself, what were the people that were making this graph thinking? I don't see a correct answer, because neither one of these cars are slowing down or speeding up, because they're both going at a constant speed. So there's no slowing down, no speeding up. Truck A is not changing speed is true. Truck B is slowing down. I don't see that. So for me, on a test, if I saw this, I'm not going to count this one against you, because there are no correct answers. If you are taking a benchmark and you see this, you're just going to have to guess the best answer that you think as to what's going on. And I don't even know what answer they would want you to put on here. So if you see that, again, the reason why this is on here is I don't want you to spend a lot of time worrying about one that just doesn't make sense. Again, there's 25 other questions or 24 other questions on the benchmark. If you see one like this that just doesn't make sense, remember, me and Miss Klein and Mrs. Weevil, we can't answer the question of this doesn't make sense. You can raise your hand, you can show me, I can look at it, I can document it, and I can email Mr. Reynolds when the test is over. But for right then, there's nothing that we can do. So just let us know and we'll take a look at it and move on. So again, if you see one that doesn't make sense at all, skip it and come back to it at the end. I'd much rather you have this one be blank or you're just guessing at the end as opposed to not knowing what the right answer is. Moving on. Below is a graph showing a change position over time for a fox and the rabbit. You can see the fox is the dot, the rabbit is the square. Based on the graph, what explains what happened to the rabbit? The fox was always 10 meters ahead of the rabbit. So yes, yes, yes. I'm sorry, no, no, and no. So they can't be A. Apologize. I was looking at the wrong thing there. The fox caught the rabbit. I see nowhere in here, especially at 80 seconds, that the fox caught the rabbit. The fox chased the rabbit, but gave up after 60 meters and turned around. So let's see. The fox chased the rabbit, gave up after 60 meters. All right, I'm stopping and turned around. Not necessarily. I do know the fox turned around, though, so I would have to say C is the best answer for that one. Moving on. Which graph depicts an object whose speed is increasing? Well, this is a distance time graph. That's at rest. That's not increasing. This is an increasing acceleration graph right here, because this next one is constant speed, and we know the answer to that one is the curved line. This graph represents two cars in a race. After 1 hour, how much faster was car A traveling than car B? You're going to have to break out and do some math with this one. But here's like, so if you have like distance after 60 minutes, so you have this one goes 70 and this one went 90. So the difference between those two is 20. You could easily use your calculator on that. But again, if this one's going, because here's like 80, 90, it's halfway between 90. This one's halfway between 70. This one's 70 miles an hour, 90 miles an hour. The difference between those two is 20. Moving on. Which graph represents a train sitting at the station waiting to depart? These are distance time graphs. So that is a constant speed. The train is not sitting still. This is a train sitting there at rest. That would be, I have no idea, train slowing down and speeding up. That's the weirdest graph I've ever seen. That's definitely not the answer. A ball is rolled away at a constant speed. What represents the motion of the ball? Well, we're looking for constant speed. It's the position time, so still the same thing as distance time. There it is, right there. Rolled away from the starting point is A. That's rolled back to the starting point, and that is sitting still. Juan goes for a run. After running for 20 minutes, he takes a 5-minute break. Let's find a graph that represents that. Well, I see him running, but I see no breaks in A. I see him running. And again, if we're looking at this one, it says after 20 minutes. So here's 20 minutes. Here's a 5-minute break, and he continues to run. I like B a whole lot. He takes way more than a 5-minute break here. And he never stops running again. So your best answer is the one above. Which graph shows a ball rolling at a speed of 2 feet per minute? I'm not going to get to that. We'll cover it later. Peace.